Hi everyone. What I'm going to do in this video is work through some of the identities with you. Now, I've made a short list up at the top of this worksheet of things that you can be thinking of when you're trying to prove that the left side of an equation equals the right side of the equation. Okay, so you might want to make a list up here because it's going to be helpful to look back on it. So, of course, we can add, subtract, multiply, and divide. Basically, all algebra rules apply here. So we can FOIL, we can factor. Of course, we can factor using greatest common factor, maybe trinomials. We can add fractions, but of course we have to get common denominators if we're going to add fractions. And we know all of those identities that we're going to be subbing in. That's going to become really, really important here. So let's go through and let's see how we do with the first few. So one thing that you have to remember is when we are proving these identities, we can only manipulate one side of the equation. So what I usually do is I look for the side of the equation where I can see more movement, more possibility to change things, substitute in, factor FOIL, all that. So when I look at this first example, I don't think there's too much that I can do with this side of the equation. So I'll put a rectangle around that. And looking at the left side, I notice that 1 over cotangent of theta, I can use my identities, my reciprocal identities, and replace that. Now remember, we do one step at a time. So I'm going to keep the tangent of theta, and I'm going to replace 1 over cotangent of theta with tangent of theta. And I don't think it's necessary for you to write the other side of the equation every single time. It's unchanged, so I leave it like that. Now, of course, tangent of theta times tangent of theta is tangent squared of theta, which we write like this. And when you do finally prove that the left side equals the right side, I do want to see both sides of that identity written out. Okay, something to remember, it's not just tangent, it's tangent of an angle. So please make sure you're putting that in there. Okay, next problem. I see more movement possibility here. So I'm going to put a little rectangle around the sine squared of theta. Now, when you look at this, we have a binomial times a binomial. And in fact, they're conjugates of each other. Remember, they look almost the same except for one has addition and one has subtraction. When we FOIL binomials that are conjugates, we have the first term squared, right? 1 times 1 is 1. But then the outer and the inner cancel each other out. So I'm not even going to write that. And now I have negative cosine of theta times cosine of theta, which gives me minus cosine squared of theta, right? Remember, cosine of theta times cosine of theta is cosine squared of theta. So you have to think, what can I do with this to make it look like this? Well, remember our Pythagorean identities and how we moved them around. We know that 1 minus cosine squared of theta is equal to the sine squared of theta. So we were easily able to show that all of this can be simplified to be sine squared of theta. Let that sink in for a second, and then we'll go on to the next few. Okay, so let's look at number 3. And again, you think to yourself, which side has more movement? I think this side does not, so I will keep that side as it is. Now, one of the strategies, and I didn't write it at the top, is sometimes we can get everything into terms of sine and cosine, and it will simplify itself. So I'm going to keep cosine squared of theta as it is, but I'm going to write the reciprocal of cosecant of theta. Now, you'll see that on your reciprocal identity section, which is 1 over the sine of theta. And secant of theta is the same as 1 over the cosine of theta. Okay, so not too much we can do here, but we can kind of treat this now because it's multiply as if it's one giant fraction. Cosine of theta will cancel with one of those cosine squareds of theta. So we'll take one of those away. And what that leaves us with is cosine of theta over sine of theta. Now keep the end in sight. We are trying to get the left side to equal cotangent of theta. And if you look on your identity sheet, you will notice that the quotient identities, Cosine theta over sine theta is cotangent of theta. So we have a simple substitution right there, allowing us to show that the left side of this identity equals the right side of it. Okay. Number 4. Again, we look, where might I be able to do more? Change things around, manipulate what's in front of me. So I look at this and I think, well, there's probably more on the left side that I can do. So I'm going to put my rectangle around the right side so it's untouchable. And once again, I see, oh, this Pythagorean identity, 1 minus the cosine squared of theta, you'll see on your note card, whoops, is sine squared of theta. So we'll replace that. And in the same step, it's okay to do two substitutions in the same step. We know that cotangent of theta, we just used it over here. Cotangent of theta is cosine of theta over sine of theta. Okay. And now what can we do? What can we do? Well, we can cancel sine of theta with one of these sine of thetas up there. Because remember, we had sine squared. And that leaves us with sine of theta times the cosine of theta equals sine of theta times the cosine of theta. Not too bad. Not too bad. All right. So, this next one's going to be a thinker. I'm even going to enlarge this page a little bit. So let's take a look here. And what I want you to notice is we have probably more movement on the left. So I'm going to put a rectangle around the right side of the equation. And I know all of these so far have been the right side where we've put the rectangle. It's not always the case, but I guess it's just how these are laid out. So if you notice on the left side of the equation, I have sine of theta over cosine of theta plus cosine of theta over sine of theta. A couple of ways we can go with this. First of all, we could say, well, this would be tangent and this would be cotangent. But I don't know if that helps us any because we are trying to get a fraction over here. We're trying to get the left side to equal a fraction. So remember, if we're going to add fractions, we must have common denominators. So I'm going to multiply the left fraction by the sine of theta over the sine of theta, giving it this factor in its denominator. And I'm going to multiply the fraction on the right with cosine of theta over cosine of theta. And what I've done there is I've created a common denominator, which is sine of theta times the cosine of theta. And now we can add. So I'll have from this fraction right here, sine squared of theta plus, and from this over here, this fraction over here, we'll have cosine squared of theta. Now, I really hope that looks familiar because that right there is the original Pythagorean identity. And we know that that equals 1. So we have 1 over the sine of theta times the cosine of theta. And again, sometimes it helps to look what we're looking to get. We're looking to get cosecant of theta over cosine of theta. So in other words, we want to keep the cosine here. And what is 1 over sine of theta? Well, that is one of your reciprocal identities. 1 over sine of theta is cosecant of theta. So that becomes cosecant of theta over cosine of theta equals cosecant of theta over cosine of theta. Woohoo! We got it. All right, I'm going to give you a moment here. I want you to pause this video and I want you to try number 6. I want you to think about getting everything in terms of sine and cosine and see if you can get the left side of the equation to equal the right side. Go for it. You got this. All right, how did you do? Hopefully you saw this was the quotient identity. This is a reciprocal identity, and then we just kept cosine. And once we did that, we were able to cancel things out and just be left with 1 equals 1. And that, of course, is what we wanted. Okay, next two. Now, I don't know, this one on number 7, I know how I did it, but I can see a case for keeping the left side or the right side. Personally, I thought it was easier. Whoops, gotta get my pen here. I thought it was easier to keep the right side. Now, if you look at this, we have sine of theta minus cosine of theta squared, which really you might want to write out sine of theta minus cosine of theta times sine of theta minus cosine of theta. And see what happens when you FOIL that. Okay, so that's your little hint for number 7. You're also going to try number 8. I think it's pretty obvious that you're going to keep tangent of theta here. Not much we can do there. And if you notice, I gave you a lot of space in here because you're subtracting fractions, which means you need common denominators. So go ahead and see if you can get these two problems. Pause the video, of course, and let's see if we get the same answers. Take your time, look at it closely. Don't get frustrated. It's all going to come together. All right, so let's take a look at this. So what I did on number 7 is I FOILed everything. So of course we get sine squared of theta minus 2 sine theta cosine theta plus cosine squared of theta. And if you notice, even though they're not next to each other, it's okay. Sine squared of theta plus cosine squared of theta equals 1. And we just bring all of this down, and that's exactly what we wanted it to equal. So it worked. On number 8, we were multiplying the left fraction by sine over sine. And hopefully you recognized that sine of theta times cosecant of theta, those are reciprocal functions. So when you multiply them, they equal 1. It's just like multiplying 2/5 and its reciprocal 5 over 2, you get 1. So we have 1 minus cosine squared of theta over that common denominator. And right here, we're back to that Pythagorean triple, the very first one that we had. This one's where we moved over the cosine squared of theta. So we get sine squared of theta, cancel out one of the sine of thetas, and you're left with sine over cosine. Our quotient identity tells us that that is tangent of theta. Okay, so there's a lot going on in here. You're going to have to study your notes, study your identities, really start to memorize them. The more you can memorize them, the easier this is going to be. Have a wonderful day, everybody.